So first, you might want to turn to this open page before day one on the back side of the cover. Just we're going to do some summary stuff real quick. So previously, we were dealing with proportions. You can kind of see how this all ties together. So if you think about it, we had the ho and the ha, and we said p equals, and we said p is either less than, greater than, or not equal to. And then we checked conditions with proportions. And when we did that, we looked at random, okay, and then we looked at large counts. And large counts is when we took n times p, and n times 1 minus p, and they both need to be greater than 10. Then we learned about the z formula, which was p hat minus p all over square root of p times 1 minus p all over n. And then we would compare p to alpha, and if p was less than our alpha, we reject the ho, the null hypothesis. And if p was greater than alpha, we failed to reject. Now remember, just like in a court of law, we never find someone innocent, we just find them guilty or not guilty. So same thing when we're looking at ho and ha, we reject the ho or fail to reject the ho. We never say, oh, the ha was right. All right. Now, we've been dealing with means lately. Okay? So here, instead of the p for proportions, where we have the ho and the ha, we have our funky u, which we call mu. And so we have mu is either going to be equal to, less than, greater than, not equal. Like that. So our mu is equal for the ho, and for the ha, it's going to be less than, greater than, or not equal. So the same thing as over with proportions, it's just a mu instead of p. All right, so for conditions, you are still going to be checking for random. Okay? And we're checking for normal, like we've been doing. So remember, n's got to be greater than or equal to 30, or they have to tell us, hey, it's approximately normal. And then down here, instead of using z, we're going to be using t. Yes, that's a t. Okay? All right. Now to the actual notes. So, for day one, testing a claim. Just like proportions, we test a claim out of mean. As we just talked about mean, steps are similar. We're going to still write the ho and the ha. That's me. We're going to use t instead of z. 3 and 4 are going to be the same we've already done. We're going to follow the same methods. And then for 5, we're going to compare, or we're going to decide whether to reject or fail to reject. And we just talked about that on the previous page, if p is less than or greater than the alpha. So a lot of similarities, just kind of tweaking some of the vocabulary. Now, what's going to change? Besides, you can always count on the board being goofy. So, first off, instead of using the population parameter of p for proportion, we'll now use the population parameter for mean, which is that funky u, which we call mu. That's the Greek letter mu. But for funky u. So, let's fill that in. The population parameter for mean u. Mu. Okay, so moving on. New stuff. instead of using a sample statistic for a proportion, a p-hat, we'll now use a sample statistic for a mean, x bar. Remember, at the very beginning of the semester, we talked about the letters lining up, proportion, p, statistic, sample, the population, proportion, and all that stuff. So we're going to use sample statistic for a mean, x bar. And instead of finding a standardized test statistic of z, we'll now use the standardized test statistic of t. It's very hard to say all in a row. All right. So let's start by writing our pair of hypotheses, the ho and the ha. All we're going to do here is write down our true mean, ho, and ha for practice. So it says, as part of its 2010 census marketing campaign, the Census Bureau advertised 10 questions, 10 minutes, that's all it takes. Because, people don't want to take a census. So people come up with a clipboard and they don't want to answer the questions. They're like, hey, 10 minutes, 10 questions is all it takes. On the census form itself, we read, the U.S. Census Bureau estimates that for average households, this form will take about 10 minutes to complete, including, so the form will take about 10 minutes, including time for reviewing instructions and answers. We suspect the time to complete the form may be longer. That's a clue there. Okay, so first off, we're going to say the true mean, or the true average. I'm not going to do this every time, but you use the word you want to write. True mean, true average, they mean the same thing. No pun intended. So the true mean minutes it takes to complete the sentence. So the true mean minutes it takes to complete census. Or survey, or whatever you want to put. Again, you get the general idea. Census, survey, whatever. Now, what are they telling us? They're telling us the mean is 10. It'll take 10 minutes. They suspect it's going to be longer than that. So the ha is greater than 10. So you identify what the true mean is. Remember the previous one we were doing the true proportion of. Now we're doing the true mean of, because we're dealing with means. It's the same format. Moving on. All right. Recently, Staff Summit has realized that the student target's first hour increased. They decided to look at the data and noticed that on average, 5 kids are targeted first hour every day. The teachers are doing a bunch of stuff, and after a few weeks, they think it's going to decrease. So, what is our statement? Our statement is the true average, or true mean, students targeted first hour. Again, you're just taking this right out of the paragraph. It's not rocket science. It's not complex. It's just, what are they talking about? They're talking about students late first hour. Again, you use the word tardy, whatever, late, students, kids, whatever. Now, what's the ho? They're saying mu is 5 minutes. The ha is, they're hoping, it's going to be less than 5, not 5 minutes, 5 kids, sorry. So right now it's 5, and they're hoping it's going to decrease. That's less than 5. One more of these. All right, rain lives in Austin, Texas. Historical records indicate the average amount of precipitation, not just rain, precipitation in Austin for the month of May is 4.37 inches. She's not sure about the validity of this claim, so she decided to test it. Now notice, she didn't say, I think that's too high, I think it's too low. She's just not sure. So, Raina randomly selects 15 households, gives permission, sets up rain gauges. By the end of the month, the average rainfall was 4.42 inches. All right? So, true mean rainfall in Austin in May. That's it. You know, you could say during the month of May in Austin, Texas, whatever. It's complex you want to make it, or it's simple. Now, what's the HO? The average they report, remember, this is all, the HO is always equal. So we're using the number they gave us. Now, she's not saying greater, she's not saying less, she's just not sure. So the HA is going to be not equal, 4.37. Whoops. I love it. Slow. Boost. See if you'll stay. Stay. Be a good board. There you go. Okay. So the same conditions we use for confidence interval must be verified before carrying on a test of significance. We kind of said this at the beginning. We got to have random. Okay. We also have to make sure that we're told it's normally distributed, or and it's got to be greater than or equal to 30. It's got to be one of those two. They need to tell us the problem, or we have to have more than 30 people. Now, this is the formula we use. And this is the definition of what they mean. So X with the bar over it is our statistic, our sample statistic, or sample mean. So this right here is sample mean. Minus our parameter, which is our population mean. Sx, remember, is our standard deviation. And obviously n is number. And don't forget our degrees of freedom over here is n minus 1. All right. Problem 1. We have to find out what t is here. Okay, we're not given t. It says find t. So we're going to do t based on the formula on the previous page. So we take our average, 37.8, and we're going to subtract our mu of 40. We're going to divide that by our standard deviation divided by the square root of n. I want to type that in our calculator. All right. So to do this, remember, easiest thing is to go to alpha y. Nope. Try it again. Alpha y. Be my friend. Alpha y. And hit enter. Oh, I don't want it there. Just be my friend. Nope. Alpha y. Y. There we go. So we hit enter there. Get a separate fraction. On the top, we're going to do 37.8 minus 40. On the bottom, we're going to put our 6.2 divided by second square root of 30. Negative 1.94. So that's my t. Negative 1.94. Okay, so we're going to look at our normal distribution. Negative 1.94, put 0, negative 1, negative 2, negative 3, negative 1.94, about there. And remember, we always shade the tail. So if it's negative, we shade left. If it's positive, we shade right. Now it says, based on this, find the p-value using your t-distribution and make a decision. Okay, now there's two ways to do this. The hard way is using the table, okay, because it's not going to be exact.
But look at your table right now. Pull up your table. Pull up your T-table. Okay? Now, did they tell us 90%, 95%? Did they do that at all? They did not do that. So, degrees of freedom is 29, right? 30 minus 1. Degrees of freedom is 30 minus 1, so 29. So what you need to do is find 29 on your chart, go right until you find where negative, and you don't look for negative because, absolute values. Look for where 1.94 would be. Okay? You see 1.699 and 2.045, right? It would be in between those two. So go up. That means it's between 0.05 and 0.025. Okay? So your p-value is between those two. Well, that makes it hard to compare a range to your alpha because it's a range of numbers. So that's kind of a pain to do it that way. So we're going to pull them away with the calculator. So if I take your calculator, hit the second button in this bars over here by clear. Second bars. In blue above it, it says DISTR. Now you're going to hit 6. That's not the right one. Didn't do it. Second bars. There we go. 6. We're looking for TCDF. TCDF. Okay? Now, if you look at TCDF, it asks for the lower number, the upper value, and the DF. So, since we're going left, we're going to put in, it's going to have this in there, just put in negative 999. Because we're trying to go as far off the chart as possible. Okay? Now, the upper value is our T that we just got. Negative 1.94. Our degrees of freedom is 29. Enter, enter. And there it is, round properly. 0.0311, because the 8 tells the 0 to go up. Okay? So for TCDF, we're going to have our low number is negative 999. We're going to write this down. Our upper number is going to be negative 1.94. My bad. 1.94. My degrees of freedom is 29. And that gives me 0.0311 for my p-value. Now we have to do one of our statements. Since my p-value, it's not going to be a big one, is less than alpha, we reject the hoe. Okay, that's it. Since my p-value is less than alpha, we reject the hoe. Okay, problem 2. This one starts off by giving us our t-value. We already know the t-value. So we don't have to worry about calculating. We already got it. So we're going to make our chart real quick right here. Negative 2.59. 0, negative 1, negative 2, negative 3. Boom. Negative 2.59. Drop it. Shade it. Okay? That's about where it is. We're going to go to our calculator and do TCDF again. We pull our calculator up. We hit second bars. Okay, we hit 6. And you might want to write this down, or you can check this on the video, but second bars 6. Lower, just keep negative 999 because it's negative. We're going to change this to what they gave us, negative 2.59. And our DF on this one, well, they told us there's 12 people. So that makes 11. 12 minus 1. Oh, my bad, it's negative, thank you. Negative 2.59. That would have really screwed it up. Enter, enter, enter. And there is our number. 0, 1, 2, careful with the rounding, 2, 6. Okay? So for my TCDF, my lower is negative 999 again. My upper is the negative 2.59. The degrees of freedom is 11. And I get a p-value of 0.0126. We always take p-values out to 4 digits. Round properly. We're comparing that to our alpha right here, 0.05. Well, 0.0126 is less than that. So again, since my p-value, and if you want to put it 0.0126 in parentheses, you can, is less than my alpha of 0.05, we reject the hoe. Problem 3, almost same thing, but notice my t is positive. Okay? So for this one, here's my 0, 1, 2, 3. 3.21 is past that border. It's this very small part of the tail. Okay? It's positive. So, I'm going to do my TCDF on the calculator. I'm just going to write this down. I'm not going to pull it up. My lower, now notice, this time since I'm going to the right, my lower is the 3.21. My upper, I'm going to put 999 positive. My degrees of freedom, well, let's see, we start with 30, so that's going to be 29. I'm going to put it in the calculator the exact same way. Second, bars. Okay, number 6, enter this data. I'm going to get P equals 0.0016. For this one, guess what? It's the same thing. Since my p-value, I can spell, I really can. My p-value is less than my alpha, we reject the hoe. So this time we had a positive one, a little bit different to mix it up. And for our last one, I'll tell you right now, we're going to finally have a p-value greater than our alpha. So real quickly, I'm going to draw my graph real quick. Notice it's negative 1.14. Negative 1, 2, 3, right there. Negative 1.14. Drop a line, shade left. All right? I'm going to go to my TCDF on my calculator. Again, second bars, 6. And I get my lower number is going to be negative 1.14. Sorry, my bad. I did that real backwards. My lower number is negative 999. So I'm going left. My upper number is negative 1.14. My degrees of freedom is 50 minus 1, which is 49. When I plug that in, hit enter, enter, I get a p-value of 0.1, nope, I'm rounding too soon, 1299. Now notice, that's greater than 0.05. So, since my p-value is greater than my alpha, we fail to reject the hoe. Don't pack up too soon, because, little surprise, your homework on page 505, this is in Canvas and Classroom, is 1, 2, and 13. And on page 534, it's 3, 4, and you can scratch 14. Okay?